Hi everyone. Hope you are doing good. So today I have to do chapter 9.3 p-value approach to hypothesis testing. If you remember last section, section 9.2, we did critical value approach to test the hypothesis test. This is a little bit similar to that critical value approach, but this is specifically p-value approach. So these are the two approaches we have to test the hypothesis testing. Okay, let's see what is this p-value approach. P-value. P-value mean probability value. P mean probability. P mean probability. So p-value mean probability value based approach. Okay, using this p-value approach, we do our hypothesis testing, uh, and we get a value. This value is probability value. This time we get probability value, and we denote this p value by using capital P. So always if I mention something like this, p val or p value, let's say simply p, it means we are considering p value. Okay, uh let's consider some kind of density curve, like normal curve, something like that. So you have learned that if I consider area from left side to this point C, we can calculate this area which I colored in red color, uh, which means the percentage of all possible observations of the variable that lie to the left of C, which means the area from left to this point, from left to this point. Same as right hand side, if I get a value d and area from d to right hand side, we call percentage of all possible observation of the variable that lie to the right of d, which means area from here to right hand side. So something like combination of these two, we can get area in between, something like this. Okay, which means area from A to B, area between A and B, percentage of all observations within A and B. Okay, I think you may remember this. We have done this in chapter 7 and also 6. So this is the basic idea behind this p value. So if p value is less than or equals to the specified significant level. What is the significant level? Which means alpha. So your p value less than or equals to alpha, what we do? We reject the null hypothesis. We reject the null hypothesis. Otherwise, we do not reject our null hypothesis. Clear? In other words, we can say, okay, this is the notation. If my p value, capital P mean p value less than or equal significant level, significant level. So it is p value less than or equal significant value. What we do? We reject H naught. Okay. Otherwise, we do not reject. That's the decision how we create or how we get by using this p-value approach. Okay. Let's see how this p-value works. First one, I consider two-tailed test. Two-tailed test, we have two sides, so we have two values. First you have to get this c value. Since this is symmetric about 0, if when you find one value C, then you can get the other value by changing its sign, you know that. Okay, so for this case, p value mean this area. Since this is two tail test, this right hand side as well. Okay, when you consider left tail test, so p value mean your left hand, this colored area. A probability or you can say percentage from left to this C naught value. And also right tail uh, curve, if you consider right tail curve, from this point to right hand side, the percentage we denote by p value. These are these p values you can find in your in your C table. In this first row you have value, this column you have values like 0.001, something like that. Using this body part, you can find this p value. Okay, because it is the area. Okay, okay. So what we need to do, these are the prominent steps what we are using to fulfill our hypothesis testing. First step, same as the previous chapter. In the first place, you have to state your null hypothesis and alternative hypothesis. Don't forget, you must mention them in the first place. Okay, then decide what is your alpha significant level. If they haven't mentioned in their question, you can easily consider your alpha is equal to 0.05 or simply 5%. Okay, same thing. Clear? uh, Next you have to compute the C value. Test statistic mean C value. Okay, then according to this alpha according to this alpha value you have to determine your p value or simply p. Now the next step is, now you have your p value and you have your significant level alpha. Compare them. If p value is less than or equal alpha, then you can simply reject your null hypothesis H naught. Otherwise, do not reject H naught. Okay, I think you remember these two words, reject null hypothesis or do not reject null hypothesis. Always we test this null hypothesis, not alternative hypothesis. Okay, okay. Uh, last step is to interpret the results based on your hypothesis test. Okay, let's see how we do this kind of p-value approach to accomplish our hypothesis testing. As I mentioned in previous slide, if I consider two-tailed test, you have two calculated C values, right? Two calculated C values. Here I'll mention how you calculate your C values. Okay, do you remember this equation last time we discussed this equation? Do you remember this one? So using this equation you can calculate C value. Into a two-tailed test, actually you need to calculate one C value, then the other one automatically change the sign. Okay, because this is symmetric. Okay, after you calculate this C value, you can find your p value using this C value. So that value we denote delta. Delta is not the p value. Okay, remember that delta is not the p value, but we can use, okay, I'll use here simply delta, so it is easy. Then we use this delta value to find p value. Okay, this is more clear. Okay, first find the c value, then find the delta value, which means the area. See, area to the left, delta mean area to the left. Then use that delta value to find p value. In two-tailed case, you can calculate your p value as I mentioned here. First, as I mentioned before, find this c value areas using c table. That value is delta. So you don't need to find both values, just just pick one value. Let's say c naught value, this one. You don't need to find these two again, just pick one and find the area. Using c table you can find the area delta. Now you can calculate your p value by using this. Your p value equals to 2 times delta. 2 times delta. Why 2 times? Because this is two-tail case. Okay. Okay. If you consider left tail test, something like this. This is your area. So again you have c naught, calculate your c naught, and then go to the c table and find what is the area belongs to the c naught. That value we call delta. Okay. Then this time in left tail test, your p value p equals to delta. You can directly assign your delta to your p value because it is left tail. Okay. When I consider right tail case, same process, you have to find this delta, but now what we have to do, your p value is equals to 1 minus delta, because this value delta means what? This delta means value from left to right. Okay, do you remember in the table, in c table, values are measuring from left to right. Okay, that's why in right tail test we get our p value by using p equals 1 minus delta. Okay, don't forget it. Okay, we will see more examples and more theory behind it in especially chapter 9.4. Okay. Okay, here I have mentioned some p values and how they affect your null hypothesis. If your p value greater than 0.1, 0.1 means simply in percentage it is 10%. Okay, so your p value is greater than 10%, which means evidence against your h naught is some kind of weak, very weak. If your p value in between 0.05 and 0.1, we can say okay, we have evidence against h naught something like normal, which means moderate. Okay, p value in between 0.01 and 0.05, which means we have evidence, we have strong evidence against our null hypothesis. And if I go further, if my p value is less than 0.01, which means I have very strong evidence against my h naught. Actually, you don't need to worry about these uh, evidence against h naught, whether this is strong, very strong. Just focus on that p value. Okay, because sometimes these can be changed because there is no specific limit for these values. Okay. Okay, uh, let's do this example. Okay, they have mentioned right tail test. I have mentioned here right tail uh, curve, normal curve. One mean C test. This is the what we are. This is what we are considering through this chapter 9. Okay, one mean C test. Okay, they have given C values. You don't need to calculate. They have given C value. It is positive 2.24, which means this side. Yes. Now you have to calculate p value based on this. First, you have to calculate what? Delta, right? Then what? Since this is right tail, what you have to do? Your p value equals to 1 minus delta. Do you remember this? Okay. Go to the C table and find the area which belongs to 2.24. Let's see. Yeah, here. Go to the table, find p value based on 2.24, right? 2.24. This is your C value. Uh, how we find this? 2.24. So first find 2.2. 2.2, where is that? 2.2 is here. Okay. Go through the column names and find 0.04. 0.04 here. So come down along this column and come along this row. Okay. You have your p value. See this one. 0.9875. This is the value. 0.9875. Clear? That is your delta. That is your delta value. How you find the p value? 1 minus delta. 1 minus delta. So 1 minus delta means 0.0125. This is your p value. Okay. Okay. In that case, you don't need to compare p value with the significant level. No, because you don't have a significant level. Okay, just find the c value. Clear? Okay. uh there is another example. This is left tail test. See, they have given left tail, one means C test. Again, they have given your C value, so you don't need to worry about the C value. They have given it is negative. Okay, no problem. So if you have left tail test, how do you find p value? Calculate your delta. That delta equals to a p value. Okay, because it is left tail test. So go to the C table and find the area uh, belongs to negative 1.58. Okay, since this is negative, you have to go to the table for part 1, which means first table. See, negative values. See, negative values. So again, I don't remember this value. Okay, negative 1.58. C equals negative 1.58. Okay, find negative 1.5. Negative 1.5 plus 0.08, right? This is how you get this negative 1.85. Okay, so first find 1.5 here, negative 1.5 here. Then use the column to find 0.08. 0.08 is here. Come along this column and come along this row. Okay, this is your value delta or probability value based on this C value. It is 0.0571. Since this is left tail, your delta equals P. Clear? Okay. Do you have any questions? Yes. Yes, we have done this one. Now they have given significance level. They have given alpha value. It is 5%, which means alpha equals 0.05. 0.05. I don't remember this alpha. Okay, we have done this. Now you have to consider p-value with your alpha value. So you know what is your p-value. Your p-value is 0.057. What is your significant level? Alpha. It is 0.05. See, they have mentioned there. This is your significant level, this is your p-value. So if you consider these two values, what you can say, this value, which means p-value, is greater than your alpha value. See, p-value greater than alpha value, which means what? If you have something like this, then you reject H naught. Okay, if not, which means if you don't have this, otherwise, sorry, otherwise what you have to do, otherwise do not reject H naught, right? Do not reject H naught. Clear? Here p value is greater than alpha value, so you cannot reject H naught. We will discuss more examples in section 9.4. Okay, okay. Let's consider two-tail test. Two-tail test. C value they have given, so this is positive. Since this is two-tail test, you should know there are two values to the C value. This is positive 2.96, the other one is negative 2.96. See, they have mentioned. Okay, okay. First thing is to determine p value. You have to find the p value. Go to the C table. Let's pick one. I don't know which one. Let's see. Okay, negative value. Go to the C table and find this area. Area belongs to negative 2.96. Negative 2.9 value is negative 2.96, right? So 0.06, this one. Come along this column, come along this row. This is your value. Delta. This is what? This is your delta. Okay. So what is p value? P equals 2 times delta, right? Why 2 times? Because this is two-tail test. See this one. So value becomes 0.003. Okay, done. What's the second one? 5% significant level. We have to decide whether we reject or do not reject our null hypothesis. Okay, now we can check it. I think p value is 0.003, right? What is your p value? Sorry, not p. What is your alpha value? It is 0.05. Okay, so you can check these two values. What happened? Not equal. Sorry, it's not equal. What happens? Your p value is less than your alpha value. P less than uh, p value less than or equals your alpha value. What you have to do? What is your decision? You have done this. Your decision should be reject H naught. Your p value, see, less than or equal 0.05 alpha. You can say less than, or you can say less than or equal. That's fine, because in the definition they have mentioned like this. So it doesn't matter if you use like this. That's okay. Okay. So you can reject H naught and you can say we agree with our alternative hypothesis. But still, you don't know how to deal with uh, this kind of problem, like after you reject or do not reject, what we have to do at the end. We will do more examples in section 9.4. Okay, okay. In this section you should know these are the things you should know. You should know how to calculate p value, You should know what is the significant level alpha. Then then compare those two values, p value and alpha value, significant level. Compare them and take your decision based on p value less than or equal alpha or p value greater than alpha, which means reject or do not reject S note. Okay, that's the main thing you should know from this section 9.3. Okay, I hope you guys get some idea how to use this p-value approach to do our hypothesis testing. Okay, hope you enjoy the video. So I'll see you in next video. Have a great day.